So, hello everyone. A warm welcome to all of you, and I'm really excited to see you all. And again, thank you so much for joining me and taking the time to be part of this session. And again, welcome to Private 5G Networks Design, Planning, and Optimization Part 5. So, we have covered a lot in the previous sessions, and today we are going to continue our journey. And here in this session, we'll go deep dive in the design, planning, and optimization. And you know very well that for
Telecom.
this private networks, I'm following the two specification of 3GPP. One is TS 23.501, that is for private network architecture, and second one is TS 23.502, that is for procedures. So these two specifications we are following in this session. So this will be the agenda. So we have already covered few topics in the previous session. So we have covered 5G building blocks for private networks. So we have covered up to here. So 6 topics we have already covered. So today we'll jump to the 7th module, which is designing the private networks. Just a quick introduction about myself. My name is Gaurav Goyal and I have more than 20 years of experience in the telecom industry. So during my career, I have had the opportunity to work with major operators and companies such as AT&T, Verizon, T-Mobile, Sprint, Dish, and also with Infovista as their product manager for their tool called Planet, which is RF design tool for macros, private planning, and all these kind of things, right? And currently, my focus is on AI, NTN, private networks, Python, and also I'm preparing for my PMP certification as well. And before we move into this technical discussion, I have shared a few links with you. So can you please confirm, are you able to open those links? So if you're able to open those links, please write yes in the chat box. Okay, thank you. Thank you.
Am I audible?
Yes, I order. As well.
Okay, so and for more details about me, you can check my LinkedIn profile and you can check my all the detailed experience on my LinkedIn profile as well. Okay. Yeah. And before we move forward, friends, I would like to share one of my favorite quotes from Albert Einstein. The only source of knowledge is experience. So we can learn a lot from books, courses, certifications, and trainings. But real understanding comes when we apply that knowledge in the real projects. So you can see some of my old ID cards here. For me, these represents my telecom journey, starting from 2G, then 3G, 4G, 5G, and now moving into private 5G, NTN, AI, and 6G. And throughout this journey, every project, every challenge, and even every problem has taught me something new. So, in today's session, my goal is not to just discuss the theory. I will try to share practical knowledge, real world examples, and lessons from my experience as well. So, like in every webinar, let's quickly go through few quotes that I personally like and would like to share with you. So, this first one has a very powerful message. Live fearless, live fearless, live purposeful. So don't be afraid of ridicule or rejection. Okay, so never be afraid of ridicule or rejection. So sometimes we do not express our ideas or try something new because we are worried about what other people might think. But if you strongly believe in something, whether it is learning a new technology, changing our career, starting a new project, or following your own idea, give it a try. So you may succeed, you may fail, but either way, you will learn something from the experience. So don't let the fear of rejection stop you. Express yourself, keep learning, take opportunities, and follow your own path. Follow your own unique journey. And this is another message that I really like. So every day we have choice whether it is our ordinary life or extraordinary life. So we can show up as an average or we can try to be extraordinary. And being extraordinary doesn't mean that we have to do something very huge. Sometimes it simply means being a little more focused, a little more committed, and putting in little more effort than yesterday. Especially in our telecom industry, technology keeps moving very fast. So we have to keep learning, improving, and challenging ourselves. So, whatever we are working on, try to give it your best. Don't just show up, choose to show up as an extraordinary, at least for today. And here is other message which I share in every class, that invest in yourself. For me, investing in yourself means keep learning, keep improving, and keep exploring new things. So read books, take courses, learn from experienced people, and most importantly, never lose your curiosity. Sometimes we become comfortable with what we already know. But if we want to grow, we have to keep challenging ourselves and developing new skills. The knowledge we build today can create new opportunities tomorrow. So, friends, always remember you are your greatest asset. So, keep learning, keep growing, and keep moving forward. And I request everyone, please mute your audio connection and please silent your phones, because there is no thing in the world called multitasking. Even a genius can do two tasks at the same time. So, to get best from this webinar, please perform only one task at a time, because better the focus, better the accuracy, and better the quality. So these things we have already covered in our previous sessions, like 5G building blocks, motivation, all these things we have covered in our previous sessions. NGM and 5G vision, how the world is moving, fourth revolution, all these things we have covered in our previous sessions. What are the three scenarios in case of IMT 2020? So I hope you have seen my previous videos for that. So if you have not, so I have shared a link for my previous videos. Please go through those links. And then we have taken some few quizzes as well. In addition to that, we have selected what are the 5G building blocks, all these things. What are the 5G performance targets? How it is different from LTE? What are the eight currencies? What are the different requirements in 5G? What are the performance requirements? What are the capabilities and free questions? And all these things we have covered, and we have checked our frame structure as well, how it is different from 4G, what is subcarrier spacing, how many different kinds of subcarrier spacing is allowed in 5G. As you know that in LTE only 15 kilohertz is allowed, and what is the difference between all these subcarrier spacing, all these things we have discussed in our previous sessions. Also, then we have jumped to our private networks, mastering the basics, right? So here we have checked what is private network, how it all started. We have checked the history. We have checked what kind of various architectures in case of private networks. What are the benefits, technologies used, all these things discussed, right? So what are the differences between private and Wi-Fi, private network enablers, MEC, network slicing, CBRS, and what are the main architecture of CBRS, what are the main tiers of CBRS. All these things we have discussed. So these things we have already discussed in our previous sessions. We have checked DB, DBM, and how to find that, and we have checked the real world example of small cells in case of Ericsson small cell R dot, and we have checked the Nokia Acer as well, right? And we have seen how to design in the design tool these things, right? So today we'll jump to our module 7, which is designing private networks. So are you excited for this part? Can you please write yes in the chat box if you're excited for this module 7? I'm very excited because this will give me real world scenarios. So I will show you real world scenarios, how to use private network in the real world, right? How to design it in the tools, maybe in the IB Wave or other tools, right? So yes, I'm very excited for this session. Okay, thank you. So all right, friends, designing private networks. So in this module, we'll go through end-to-end process of designing a cellular private networks. So we'll understand different stages of cellular private network project deployments, right? Then we look at how we can design an indoor private networks using small cells. And after that, we'll see how prediction heat maps helps us analyze the RF coverage and optimize the design. So the focus here will be very practical, like requirements, planning, RF design, small cell placement, predictions, testing and validation, and optimization. Right. So we'll try to cover as much as possible in next 1 hour or so, and rest we can cover in the next session. So designing private networks. So before we start designing a private 5G network, it is important to understand the complete project life cycle. So a successful deployment is not just about RF design. It starts with understanding the customer requirements and use cases. Then site surveys, network planning, design, deployment, testing, optimization, and finally the acceptance. So acceptance, when acceptance is done, only then we get the payment. So this is one of the most important steps. So let's go through the project deployment process step by step and understand what happens at each stage. So these are the few stages for designing a cellular private network, or you can say that for implementing or deploying a private cellular network. So we can broadly divide the project into 5 stages. One is requirements, planning, design, implementation, and the operations. So we'll start with the requirements. So what does the customer actually need? What are the use cases? Coverage expectations, number of users, devices, performance requirements, and so on. These things are covered in the requirement. Then comes the planning. So here we perform the site survey, estimate the coverage and capacity, understand the spectrum and licensing needs, and identify the appropriate equipment and the vendors. Next is design. This is where we decide the actual network configuration and placement of small cells or the access points in case of Wi-Fi. So once the design is finalized, we move to the implementation, installing and configuring the radios, network equipments, code, and the integration and testing the complete solution. And finally, we have operations. So once the network goes live, our job is not finished. Continuously monitor the network against the defined KPIs and identify the performance issues and optimize wherever required. Right. So think of its end-to-end journey as requirements, planning, design, implementation, and operation. So in next few slides, we'll take these stages one by one and look at what actually happens during a real private 5G deployment. So now we come to the first and probably the most important steps, that is requirements. So before we place even a single small cell, we need to clearly understand what the customer actually wants to achieve with this private 5G networks. So first is the purpose. So what's the purpose of the network? Is it for smart factory, warehouse, hospital, airport, office, or maybe a data center? What problem are we trying to solve? Next is, who are the users? So are these employees, visitors, contractors, or machines? So are these machines are stationary or will they be moving around the facilities? As you know that nowadays we have AGVs, robots, scanners. So some are stationary and some are moving around the facility as well. Then we need to understand the devices. So are we connecting only smartphone and tablets, or are we supporting like cameras, sensors, robots, AGVs, scanners, and other IoT devices as well? After that comes the actual design requirements. So here we need to know what coverage do we need, what kind of data will be carried, what throughput and signal quality are expected, are there any interference or latency requirements, and finally we have security. So private networks are often carry business critical or sensitive information, so we need to understand the required level of security and the access control. So again, not start designing until you understand all these 5 points, because those 5 points will drive almost everything. It may be coverage, capacity, spectrum, small cell count, placement, all these things, and ultimately the cost of the network. So before properly understanding a requirement, if we start deploying the network or design the network, I consider it as a suicide. Okay. The second step in deployment process is planning. So once the requirements are clear, we have to plan our network. So this is where we start translating the customer requirements into actual network plan. So here we have to follow four keys areas. So first is the site survey. So we need to understand the physical environment. We have to understand the building size, number of floors, wall materials, ceiling heights, equipment locations. We have to understand where coverage is required and where coverage is not required. So there may be some restricted areas, right? And where coverage is critical, less critical. So we have to know this by the site survey. Second is coverage and the capacity estimation. So coverage tells us where we need the signal, but capacity tells us how much traffic the network needs to support. So we need to consider the number of users and devices, expected throughput, applications, and the peak traffic as well. The third is licensing and the spectrum. So we need to determine what spectrum will be used. For example, in case of US, for private 5G deployment, generally we use CBRS, 3.5 gigahertz band. And finally, we have equipment and the vendor selection. Based on the requirements, we can identify the appropriate small cells, radios, core network, switches, and other infrastructure as well. For example, mainly we are using for radios, we are using like for GMA, we are using Cell Hub. For Ericsson, we have R dot. For Nokia, we have like CBRS, small cells or ACIR solution, right? And then for Celona, we have AP11, AP12, depending on the indoor or the outdoor solution. And last one is the Highway 9. So it can be have outdoor 4G access point. So these are the 5, 6 main radio companies we use for EOC as well as RFPs, right? So depending on the need or depending on the cost, we'll see which one we have to use for this particular private network. Okay, so first step will be the site survey in the planning. So why we need site survey? As you know that a floor plan can give us the dimension, but it can't always tells us what is the real RF environment looks like. So when we physically visit the site, we can understand the building, the construction materials, the user location, and possible installation challenges. Right? These can be possible only when you do the site survey. So the first thing here we need to understand is the coverage area. So here we have to check various things like how large is the building, what's the coverage area, is it 500,000 square feet, 1 million square feet, these kind of things. How many floors we have to cover? Do we need coverage everywhere or only in the specific area? For example, do we need coverage only in the production area, warehouse, offices, conference room, loading docks, or any specific area? Right? And there may be some restricted areas where coverage is not needed. So during the survey, we clearly identify the areas that are in scope and out of scope. Also, we can determine which are the critical areas and not so areas. Right? This we can see. The second thing we look at is the characteristic of the environment. This is extremely important from an RF perspective because different building materials affect the signal differently. We may have concrete walls, metal structures, glass, elevators, different kind of equipments, metallic racks, and other obstacles that can impact our RF propagation. For example, in warehouse, we may have high ceiling and large metal storage racks. So in a manufacturing facility, we may have heavy machineries and lot of metallic infrastructures. We may have AGVs, robots, scanners, sensors, cameras, all these things may be there. Moreover, if an existing RF is available, we have to check that as well. So all of these things need to be considered when we design the network. So we also want to understand where the users and devices are located. So as I said earlier, private network is always about everything. It's not about only smartphones. It can be scanners, it can be tablets, cameras, sensors, robots, AGVs, and various IoT devices. So some areas may have few devices and other location may have high concentration of devices. So we have to take care of coverage and capacity according to the concentration of devices as well. The third thing is the areas. So, as I said earlier, not every area has the same coverage or ST requirements. For example, conference room may have strong coverage because many users could be connected at the same time. So, it has strong coverage requirement. In factory, production line is very critical, right? So it has strong coverage and capacity requirements. So we need to talk with the customer and identify the critical locations during the survey. And we should also understand whether there are any specific performance expectations, like in higher throughput, right? Some areas may have high concentration of devices. So those areas may require higher throughput, low latency, and the reliable coverage. So we have to identify those locations as well. So this is where RF design and practical deployment requirements come together. So from an RF perspective, a location may look different from our IB wave tool, right? So uh, site survey is like a combination of our design and real time environment. So with the help of site surveys, we have to ask many other questions. So when we go to site, we have to ask many other questions like, is the power available? Can we provide backhaul connectivity? Is the fiber route is there? Can we run the cable from network room to that location? Right? Is the ceiling accessible? Are there any installation restriction? And very importantly, can the maintenance team easily access that equipment later if troubleshooting is required? So we also need to identify locations where installation is allowed and where installation is not allowed. This is very important, and we have to check various other things like power, backhaul, and accessibility, right? And sometimes the customer may have restricted areas, architectural limitations, safety requirements, or other constraints. So we should document everything during our site survey. We can take pictures, mark possible equipment locations on the floor plan, and identify cable routes. We can identify the material of the walls. We can identify the ceiling heights, where is the network room, how is the power availability, and any potential installation challenges. So if an existing wireless network is already available, we may also collect the RF measurement to better understand the current RF environment. So as I said that site survey connects the design, or you can say that theoretical design, theoretical design plus real world environment. The better our site surveys is, the better information we have when we start placing small cells and running our RF predictions. And once we have collected all this information, we can move to the next step and we can determine how much coverage and capacity the private 5G network actually needs. So now we have completed the site survey. As I said, the next important part of planning is coverage and the capacity estimation. This is where we start converting everything we learned during the site survey into actual network design requirements. So there are two things we need to understand here. One is coverage and one is capacity. These are related, but they are not the same things. So coverage tells us where the signal needs to reach, but capacity tells us how much traffic the network needs to support. So let's start with the coverage requirement. During the site survey, we identified the building layout, number of floors, critical areas, wall materials, equipment locations, and different areas where users and devices will operate. Now we need to define how much of that area needs wireless coverage. For example, does the customer require coverage across 100% of the building, or maybe 75% of the building, or there are certain areas that can be excluded. Right? So there may be locations such as washrooms, mechanical rooms, storage rooms, elevators, and other low priority areas where dedicated coverage may not be required. At the same time, there may be some critical areas where coverage is extremely important. For example, conference rooms, executive rooms, production areas, warehouses, loading docks, control rooms, or location where business critical devices are operating. So instead of simply saying we need coverage in this building, we need to clarify and we need to clearly define where coverage is required and what is the level of coverage expected. The next step is defining our RF performance targets or the KPIs. For example, we may define target values for RSRP, RSRQ, SINR, and the MADR, minimum acceptable data rate. So these become our design benchmarks. So later when we create the RF prediction in planning tool, we can compare our prediction network performance against those targets. For example, if a customer requires a certain minimum RSRP throughput, the critical coverage area, our design needs to demonstrate that we can achieve that target. For example, for the VP room, right, vice president room, or other executive room, or in the conference room, our requirement is that NAC 90 dBm for 100% of the room. So we have to show that that coverage should be met. Similarly, we have SINR, which is very important because only the strong signal is not enough. So we also need good signal quality. So coverage planning is not just about asking, do I have a signal? The better question is that, do I have enough signal with sufficient quality to support the required service? Because now we'll jump to capacity, but as you know that capacity is equal to bandwidth log 1 plus sin r. So higher the sin r, higher the capacity. Now let's move to the second part, which is the capacity. So this is equally important. So imagine we have excellent coverage throughout the entire building, but hundreds of users or devices are trying to use a network at the same time. They want to use the Netflix, they want to use the YouTube, or they want to do the office work. And the network can't support the traffic. Technically, we have coverage, but the user experience is still be poor. So there is no use of that coverage. That's why we need to estimate the capacity demand as well. So here, first we need to understand the number of users and the number of devices. So we have to understand how many users are expected on each floor, how many devices will be connected, are they evenly distributed across the building, or there are some specific hotspots where many devices will be concentrated. For example, maybe one floor has 50 users and other floor may have 3,000 users, right? So, or perhaps a warehouse has hundreds of scanners, cameras, AGVs, robots, sensors, or connected machines operating simultaneously. So these areas may require significantly more capacity. And we have to understand the type of traffic well. So the question is that, are we primarily targeting data or voice services or both? Are we supporting video surveillance or not? Are we do have industrial applications, IoT sensors, robots, or AGVs, right? Because we know that different applications generate different traffic requirements. For example, IoTs may not have high requirement related traffic. They only needs a small amount of data. But a high definition camera, right? Camera need high uplink capacity, right? So we can't simply count the number of devices. We need to understand what those devices are actually doing on the network, because some require high uplink capacity, some require high downlink capacity. So we can't internalize the required throughput. So uplink and downlink throughput becomes very important, especially in the private 5G, because some enterprises like traditional offices here, downlink traffic may be more than uplink traffic. But in, like I said, that in case of security cameras, uplink traffic may be more than downlink traffic. So traffic profile can directly influence how we design the network. So this is very important. After that, we have to check typical user profile and the peak hour demand. So we normally do not design only for the average traffic in case of private networks. We also need to understand what happens during the busiest period. Maybe there are 500 registered devices, but only 100 are normally active simultaneously. So we have to design our network according to that. And other thing we have to consider is SISO and the MIMO as well. So number of streams, right? So MIMO can improve our spectral efficiency and throughput. We know it very well. But the actual performance depends on the radio configuration, RF environment, signal quality, and various other things. So all of these things or all of these inputs are very important for designing the network. So we have to design coverage plus capacity both, keeping in mind, right? Because sometimes a single small cell may provide enough RF coverage for a large area, but from a capacity perspective, one small cell may not be enough. So we need additional small cells, not because we have a coverage problem, but because we have a capacity requirement. And that distinction is very important in the real world network design. So whenever you're designing a private 5G network, always think about these questions together. Can we provide enough RF coverage? Can my network support expected number of users, devices, applications, and the traffic and as well? So we can't separate capacity from coverage, at least in case of private networks. So let's take one capacity estimate example. So this table basically shows typical data consumption and average throughput assumptions for different types of venues. So now this is a good example of how capacity requirements can vary depending on the type of environment. So we may have various locations like airports, cafeterias, conference rooms, university campus, all these things. For each environment, we can see that the estimation of how much data a typical user may consumes over cellular and Wi-Fi is depending on the environment. So let's take the example of airport. Here the assumption is approximately 176 MB of cellular data over a 2-hour period. So when we convert that data consumption into an average data rate, it corresponds to 201 kbps per user. Now this number may look quite small compared with the 100 Mbps, 500 Mbps, or even gigabyte speeds we normally discuss in 5G, right? But there is an important distinction here. This is the average throughput demand, not necessarily instantaneous peak speed experience by a user. So a user may download something at 50 Mbps or 100 Mbps for a few seconds and then generates almost no traffic for next several minutes. For capacity planning, we are interested in understanding average traffic behavior, average as well as peak behavior of the users. And there are various other examples, like in conference room, we have 102 MB of cellular data, 233 kbps of output. So now imagine that conference room has 3 active users. So very roughly, we can start estimating the aggregate traffic by considering 50 multiplied by 233. So number of active users multiplied by average throughput per user. In the real world, we don't stop here. We have to know about simultaneous uses, discover traffic, application types, peak throughput, and required quality of service. Let's take the example of university campus. So here we see significantly higher Wi-Fi consumption of 787 Mbps. The throughput is very less, which is just 1.75 Mbps. So different environments can have different traffic profiles. This is exactly when designing a private 5G network, we should not simply say that there are 500 users. So I need these many cells. So we have to take care of how many users are active simultaneously, what application we have to support, what is the busy hour traffic, what is the busy hour demand, and how much is the uplink and the downlink traffic demands. This is why capacity planning must always be based on the actual use case and customer requirements rather than single generic traffic consumption. So, friends, are you following what I'm saying? Can you please write yes in the chat box if you are following what we are discussing for last 50 minutes? Thank you. Thank you. Okay. Now let's talk about one of the most important consideration in the private 5G planning. It is licensing and the spectrum. So once we know our coverage and capacity requirements, we need to decide what spectrum or what license the network will use. So for private 5G deployments in United States, we know that we use CBRS. And we have already discussed in our previous sessions that CBRS use a three-tier spectrum sharing model. So we have first in tier one, we have incumbent. In tier two, we have priority access license. In the tier three, we have GAA, General Authorized Access. So we have discussed all these things in detail in our previous sessions. So please go through my recordings, and I have already shared the YouTube links with you. So please go through those links and you will get more clarity of these three tiers. But in the real life, for many enterprises, private LTE or private 5G deployments, generally we use GAA because we don't have to spend money on the PAL. But this doesn't mean that we can simply select any CBRS frequency and start transmitting. The CBSD. Anybody, what is CBSD? We have discussed in the last class. What is CBSD? So we have discussed that. Thanks for the right answer. Yeah, CBSD is Citizen Broadband Service Device. So in CBRS, if we call a radio or small cell as CBSD. And what are the various kinds of CBSD? We have all discussed in detail in the last class. So please go through that as well. So the CBSD has to communicate and coordinate with SAS, right? For proper configuration. We have discussed that in the last class, like spectrum access system, and the SAS manages spectrum availability and tells the CBSD which frequency and power level it is authorized to use. So when we say GAA is generally available, remember that it is still a managed shared spectrum environment. Now, depending on the business and technical requirements, an organization may also consider PAL spectrum. PAL provides priority over GAA users, right? You know that PAL has more priority than GA, and incumbent has more priority than PAL and the GA. Why might PAL be attractive? Even then, we have to pay money for that. Why it is still attractive? So one consideration could be large and important coverage area, especially where higher power category B CBSDs are being deployed. And other criteria can be mission critical environment where stable spectrum access can reduce exposure to interference from GAA users, right? It's a very critical area. So we have to remove interference from GAA. So that is also one of the reasons to buy PAL. And other situation could be multiple CBRS networks are operating nearby. For example, imagine an industrial campus where our private 5G network is operating, but neighboring enterprise are also deploying CBRS networks. So if everybody is relying on the shared GAA spectrum, availability and interference conditions can deteriorate. Right? So we have to take care of that. So in that situation, having PAL rights can provide priority over GAA use, right? And if incumbent is there, we have to give priority to the incumbent. So during the planning stage, we need to ask like what spectrum is available? Are we using GAA or PAL? What other CBRS networks are operating nearby? What kind of interference we are expecting? What type of CBSDs we are deploying? Are we category A or category B? And ultimately, can the selected spectrum support our required coverage, capacity, and other performance targets? So once the spectrum strategy is clear, we can move to the next planning activity, which is selecting the right equipment and the vendors for the private network. So next step is equipment and the vendor identifications. So selecting the right equipment and vendor is critical because it directly impacts the coverage, capacity, reliability, and all other performance targets of the private 5G network. So how to select equipment or vendor? Right? So first we evaluate the radio or small cell solution. So we need to check which frequency bands are supported. For example, for CBR's deployment in the US, we may need band 48 or N48. N48 for LTE and N48 for 5G. So we also look at the transmitter power, channel bandwidth, MIMO capability, number of supported users, coverage capability, capacity capability. All these things we have to check. We also need to determine whether we need indoor cells, outdoor cells, or the combination of both indoors as well as outdoor cells. But remember that private network is not only about radio. We have to take care of many other things, like we have to take care of core network. We have to take of transport network, or you can say backhaul. And then we have to take care of switches, network management platforms, SaaS integration, and enterprise network connectivity. So the customer may be using smartphones, tablets, scanners. So we have to take care of all these things because device compatibility is also very important in case of private network design. Then of course, we need to consider the project, budget, and the ROI. And we should not look only at the initial equipment cost. We also think in terms of software licenses, installation, maintenance, support, and future upgrades as well. So vendor support is also important. So if we have network issues after deployment, how quickly can the vendor provide the technical support? What is the escalation process? How quickly can failed equipment be replaced? And finally, after evaluating the technical requirement, cost, scalability, and the vendor support, we should have shortlist the number of equipment vendors and vendors for the design. So for a large and more critical deployment, we may have to do point of, we have to do POC, we have to do proof of concept. So I have done many proof of concepts in the past for private networks, for DAS, because you know that DAS is continuously upgrading. For example, in case of Comscope, we have earlier we have Ion B, Ion U, and then we have Ion E. In case of Corning, earlier we have 1000, now we have Corning 1000, and now they are shifting to Corning 6000 as well. Same story is with solid dash and ADRF dash as well. And in case of private networks, as I said that I have done proof of concepts with Nokia radios, Ericsson R-Dot, Celona, Highway 9, all these things, right? So we can validate things like coverage, throughput, latency, device connectivity, and the application performance during the proof of concept as well. So once we have finalized our equipment, we can move into the next stage, which is actual private 5G network design. So the next stage is the design. So during planning, we identified the customer requirements. We completed the site surveys. We have estimated the coverage and the capacity. We have reviewed the spectrum requirements, and also we have shortlisted the equipment and vendors. Now, in the design phase, we take all of that information and convert into the actual network design. So there are two major areas we need to focus on. First is component configuration. Second one is component placement. Let's start with component configuration. So first we need to define the TDD configuration, which determines the balance between uplink and the downlink resources. This is very important because different private 5G applications have different requirements. As I said earlier that Like office requirements may have more requirement of downlink capacity, but video cameras. So a factory that supports a large number of video cameras may require significantly more uplink capacity. Right. So we have to take care of this. Then we have channel configuration and the bandwidth. So are we using 10 megahertz, 20 megahertz, 40 megahertz, or another available bandwidth? So generally, more bandwidths can provide more capacity, but actual configuration depends on the available spectrum and the network requirements. Then we have number of streams and the MIMO configuration. So this will impact achievable throughput and the overall network capacity, right? And after that, we have to take care of equipment and antenna characteristics. It may be their transmit power, it may be their antenna gains, antenna patterns, and all these things. Once these parameters are defined, we move to the component placement. So now here we determine where the small cells or radios should actually be installed. And this is where our site survey becomes extremely useful. So we place the radio based on our coverage, quality, interference, and the capacity requirements. As you know that for coverage and quality, we look at KPIs like RSRP, RSRQ, and the SINR. At the same time, we need to make sure that our capacity requirement should also be fulfilled. All the devices should get the minimum throughput. So once the initial design is completed, we perform RF prediction and design validation. We compare the predicted performance against the KPI we defined earlier. If the design meets the coverage, quality, capacity targets, then we can move forward. But if doesn't meet the target, we go back and optimize our design. We may change the small cell locations, we may change the antenna configuration, transmit power, or we may have to add other small cell as well. So network design is normally an iterative process. So we design, predict, validate, optimize, and validate again until the required capacities are achieved. The next step is the implementation. So once the design phase is completed and validated, the project moves into the implementation phase. So this is where our design moves from planning, tool, and floor plans into the real world network. The first step is to install and configure the small cells or radios according to the validated design. The installation team needs to follow the design locations, correct heights or correct mounting heights, antenna orientations, and other specifications. And we also need to connect each small cell to the required power and the backhaul infrastructure as well. This is important because even a good RF design can perform differently if the equipment is installed at a different location. Right? So location, height, orientation, all these things are very important. Next, we need to install and configure the core network if it is not already available. Nowadays, core can be on the premises, can be at the edge, or it can be in the cloud. Nowadays, people are shifting towards the cloud. So most of the core are in the cloud. And we also configure the required network parameters and make sure that radios, transport network, core, and enterprise are communicating properly. Once the basic once the basic network is operational, we start the testing and the validation process. So first we verify the devices can successfully connect to the private 5G network. We will check can the UE can register, can it obtain an IP address, can it communicate with the required application or server or not. Then we start checking the RF performance for other KPIs like RSRP, RSRQ, SINR, uplink download throughput, latency, mobility, all these things. But one thing we should very clear, we should not test under only the ideal conditions. We should test the busy hour or worst case scenarios as well. For example, what happens when many users or devices are connected simultaneously? Does the network provides the required throughput still or not? Right? So what happens when users move from one small cells to other? Are they handed over properly? Right? So we have to check because network is supporting various kinds of different devices like cameras, robots, scanners, AGVs. and other devices. So we have to take care of that. Another important step is to compare the actual field requirements with the predicted design. As I said earlier, that during the design phase, we predicted that what the network should achieve. But after the implementation, we are measuring what the network is actually achieving. So if the results are close to our prediction, our KPIs, then that's good. But if we find coverage holes are there, signer is poor, high interference is there, low throughput is there, then we need to investigate and optimize. We may need to adjust our small cell locations, transmit powers, antenna configuration, and heights, orientation, these kind of things. So implementation is not simply about installing the equipment. It is all about optimizing the network so that our KPIs requirement can be fulfilled. And then we have this operation. So once the network has been installed, tested, optimized, and accepted, we move into the final phase, which is operation. So network is now live, but our work doesn't stop here. During the operation, the main objective is to make sure that private 5G networks continues to provide the coverage, capacity, reliability, and the performance that we originally designed it for. So first important activity is the KPI monitoring. So we continuously monitor network performance using these main KPIs like RSRQ, SINR, throughput, uptime, accessibilities. All these things are required to check the performance of the network. But we have to do continuous monitoring because maybe at 2 p.m. all these parameters are okay, but at 5 p.m. those parameters may not be okay. So continuous monitoring helps us identify these changes before they become major problems. The second major activity is monitoring alarms and the alerts. The network management system can generate alarms for different problems. For example, a small cell is down, a backfall failure is there is some sync problems. So all these things can be done with the help of monitoring alarms and the alert. For a CBRS network, we also need to monitor the interaction with the SAS, Spectrum Access System. The SAS manages spectrum authorization for the CBSDs. And if spectrum availability changes, the SAS may instruct a CBSD to change channels, reduce power, suspend transmission, or relinquish the grant, depending on the situation. So we need appropriate monitoring alerts to make sure that operation teams knows the spectrum related events occur. Another important thing is troubleshooting and optimization, right? So if user starts reporting poor coverage, low throughput, dropped connections, or application performance, we need to investigate the root cause. It may be due to RF. So we have to check, is it RF issue? Is it interference issue? Is it capacity congestion issue? Or is it due to backhaul? Is it due to core problem? Is it application or device issues? So if there is a problem, we can't blindly say that it is only because of RF. So there may be some other problems involved. So operation is really a continuous cycle of monitoring and identify problem and troubleshooting and finding the solution. So goal is to make that private 5G network doesn't just perform well on the day it is launched, but continues to meet the requirements KPIs, right? So before jumping to next session, let's have a quiz. Can you please answer this question? Which of the following options indicate the phases of a private network deployments in the correct order? Please give me answer one to one in the chat box. Thank you. Yes. So right answer is A. Requirements, planning, design, implementation, and the operations. Can you answer this question as well? Exactly. Very nice. Its answer is B. Because location of major obstructions is not the requirement. It is the finding. We do it during the site survey because this is a part of information gathered in the site surveys during the planning phase. So this is the right answer, location of major obstruction in the building. Last question. Yes, it's quite obvious. So answer is C, which is RSRQ, RSRP, and the signer. Okay. So now let's move to the next topic, which is the design example. How to do in the real world a design of a private networks. I think we have already covered too much. I think this topic will be covered in the next session. So let's wrap up this session. And so in the next session, we'll discuss all these things in the real world scenario. So we'll discuss all these things in the next session, right? So in this session, we have already covered the theory of private network design, but in next session, we'll take about the real world example, right? So we have covered all these things. So in the next session, we'll start with the design example, and then we'll discuss about the output maps for the cellular, and we'll talk about in details private network throughput and capacity and KPIs and optimization. So with this topics, our complete course of 5G networks designing, deployment, testing, troubleshooting, and the acceptance course will be completed. And before we leave, I want to give you one message I strongly believe in. So, winning is a combination of passion, skill, experience, and have a clear target. But none of this happen overnight. Technology, especially telecom, is changing continuously, right? So, we moved from 2G to 3G, then 4G, 5G, and 6G is awaiting. And now we are talking about private networks, AI, NTN, all these things. So, keep training, keep learning and keep practicing and keep improving until you get it right. Your experience gives you a foundation, but continuous learnings keeps you relevant. So never stop being curious and never stop investing in yourself. Again, friends, this is Gaurav Goyal. And for more details about me, you can check my LinkedIn profile because I regularly share technical posts and telecom updates there. And also, please follow me on LinkedIn for updates for upcoming webinars as well. I hope you all, everybody has the link. Okay. So you can go to my LinkedIn profile and please follow me on the LinkedIn for the upcoming webinars. All right, friends. So we have reached the end of today's webinar. So a big thanks you to everyone who joined and stayed with me throughout the session. And I hope today's discussion gave you something useful knowledge and the practical takeaway. As you know that technology never stands still and neither should our learning. So we should always stay curious and continue moving towards our goals. So again, friends, take care of yourself, your family, and stay motivated and keeps a positive mindset. And thanks again for joining me today and take care and see you next time. Thank you.